Hello, and welcome to Algebra 2, Chapter 5.3, Solving Quadratics by Factoring. Do remember, when you solve a quadratic, you're looking for a root, or a zero, and that is an x-intercept, so it's the place it crosses the x-axis. And so one way you can solve them is by graphing, but if it doesn't cross exactly at an integer, then it's hard to tell the answer. And so in 5.2 we investigated solving by factoring, and actually, hold on, this is not solving by factoring. This is solving by taking square roots. That might not be the exact title, but that's what we're going to go with. Sorry, 5.2 is factoring, 5.3 is by doing square roots. So, just to refresh your memory on a square root, it is one of two identical factors. Remember, factors are things that you multiply together. So what are the two identical factors of 16? Well, they happen to be 4 times 4. So that means that the square root of 16 is 4. It's one of those two identical factors. A positive number has two square roots. Okay? And so actually, square root of 16 equals 4. Square root of 16 also equals negative 4, because negative 4 times negative 4 is also 16. So something to keep in mind there is that not only does a square root have a positive answer, but it also has a negative answer. So the radicand is the number beneath the radical sign, and a radical is any expression with a radical sign. So real quick, if you're going to solve the square root of 25, it is plus or minus 5. So remember that for the most part, solving a quadratic, they have two answers. So if you're looking at something like that, we have two answers, and so this is then how you get those two answers. So we're going to just do some basics with square roots first in case you've forgotten them. We have the product property, which says if you take the square root of a times b, you can break it apart into the square root of a times the square root of b. So for instance, the square root of 36 is the square root of 4 times 9, because that's still 36, and so that can be broken apart into the square root of 4 times the square root of 9, which is 2 times 3, which is 6. And we also have the quotient property, and the quotient property makes it really nice to take square roots of fractions. So if we took the square root of 4/9, that would be the square root of 4 over the square root of 9, which is 2/3. And I am going to expect to see those as fractions and not as decimals. Okay? And so a square root expression is considered simplified if there's no radicand that has a perfect square factor other than 1, and there's no radical in the denominator. Okay? So we'll talk about those two things coming up here. So first of all, we want to simplify a radical. And to do that, we're going to look to see is there a perfect squared number that goes into it. So a list of our perfect squared numbers, you have 1, which doesn't do anything for you really, but 4, which is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, and you should be able to go higher than that. And so the question is, do one of these numbers go into 500? And in fact, what is the greatest of these numbers that goes into 500? So the answer there would be 100. So you could rewrite 500 as 100 times 5. And then from our product property, it says this is the square root of 100 times the square root of 5. Well, what is the square root of 100? It is 10, and then you keep that square root of 5. So that is the square root of 500 simplified. By the way, if you put them in your calculator, both the square root of 500 and 10 square root of 5 will give you the same decimal. And notice I did put the one that I could take the square root of first. I think that's easier because that's going to be the number out front. So looking at 3 square root of 12 times the square root of 6. And you could simplify them both individually, or in fact you can multiply them together and then simplify. Oh, let's go ahead and do that. Let's go ahead and multiply these together. So this is going to be 3 square root of 72. Okay, and then I'm going to look at this list of perfect squares over here and say, well, which of those is the greatest number that goes into 72? And I believe the answer is 36. And so then I can write this as 3 square root of, I'm just going to write it as 36 times 2, which is the same thing as the square root of 36 times the square root of 2, which is 3 times 6. And don't ask me why my square root of 2 changed to a square root of 3. These things are magical. Okay, square root of 2, 18 square root of 2. You're going to multiply those together. There we go. So the next part of when is a radical simplified is when there's not a radical in the denominator. But sometimes you get a radical in the denominator, and there can't be one in a final answer. So to get rid of the radical in the denominator is called rationalizing the denominator. And it's a process of multiplying both the numerator and the denominator by the same radical expression. And the purpose for this is to eliminate the radical from the denominator. And so if you're multiplying by the same radical expression, so you're multiplying by the square root of x over the square root of x, well, anything over itself is just 1. So I'm not necessarily changing the number, I'm multiplying by 1 to change the form of my numbers. So square root of 25 thirds. So this doesn't work as nicely as it did when I showed you the quotient rule, because I can take the square root of 25, and in fact I'll go ahead and write it like this. You know, this is 5 over the square root of 3, but I can't take the square root of 3. And so we're going to rationalize the denominator by multiplying the top and the bottom by the square root of 3. The reason is, on the bottom, when you multiply the square root of 3 times the square root of 3, there's several ways to think about this. You get the square root of 9, which is just 3. And the other way to think about it is anything times itself is squared. A square root and a squared undo each other, and then you just get 3. So here I have 5 square root of 3 over 3, and you leave it like that. There's nothing else you can do with it. Square root of 3 cannot be simplified, and you no longer have a square root on the bottom. So the second one here, using my quotient property, this is the square root of 2 over the square root of 11. Cannot simplify the top. The bottom, though, I can't have because it has a square root of 11. So I'm going to multiply by the square root of 11 over the square root of 11. On the top, you get the square root of 22. That's your product property. On the bottom, you get 11. There we go. So we're going to use this property to solve quadratic equations. And the deal is, if it's in the form x squared equals s, all you have to do is take the square root of both sides to get x, and you're going to get two answers. You're going to get x equals plus or minus the square root of s, whatever that is. And we do need to make sure that whenever you take a square root of something, that you can only take square roots of positive numbers. And so if what you're taking the square root of is positive, then you are going to have two real number solutions. So it has to be in the form, though, x squared equals s. And so you need to do some rearranging here. This is going to be negative 5x squared equals negative 12. I'm going to divide by negative 5. X squared equals 12 fifths. So from this point, you're going to take the square root of both sides. So x is going to equal, because remember I said a square root and a square cancel. So x is going to equal plus or minus the square root of 12 fifths. But I'm not going to write it as the square root of 12 fifths, so I'm going to come down here. I'm going to multiply by the square root of 5 over the square root of 5. This is the square root of 60 over 5. And 60 simplifies into the square root of 4 times the square root of 15, So we're looking at 2 square root of 15 over 5. So I'll come back up here, and it's plus or minus 2 square root of 15 all over 5. That is what x equals. So those are two answers. Those are the 2 points where that parabola would cross the x-axis. Okay, so this one we're going to have actually in a slightly different form. First of all, I want to get rid of that 3. You cannot distribute it because you have a squared there. You cannot distribute anything into those parentheses until that squared is gone. But that's fine because I'm going to actually divide by the 3 and get that without foiling. The whole point here is to not foil. I can go ahead and take the square root of each side. This is x minus 2 equals plus or minus the square root of 7. Square root of 7 does not simplify, but I still need to get x by itself. When you write this, you should write the 2 first. That is your answer. 2 plus or minus the square root of 7. That is 2 answers. That's 2 plus the square root of 7, and that is 2 minus the square root of 7. And you don't necessarily have to write them out. You just have to write it as 2 plus or minus the square root of 7. Okay, so 2 more here. So first of all, remember our goals of getting x squared by itself. So 4x squared equals 48. Divide by 4. X squared equals 12. And then I want to square root both sides. And so plus or minus, well, 12 breaks down into square root of 4, square root of 3. So this is going to be 2 square root of 3 because the square root of 4 is 2. And for the other one, we're going to multiply by 5 and get x minus 4 squared equals 30. And then I'm not going to FOIL that out. I'm just going to square root both sides to get x minus 4 equals, and square root of 30, let's see here, 4 doesn't go into it, 9 doesn't go into it, 16 doesn't, okay, it's good. So we're going to add the plus or minus though, square root of 30, and then we're going to go ahead and move 4 to the other side, and so it's going to be 4 plus or minus the square root of 30. Okay, 2 more examples. Well, this one is actually not an example, but it's showing you that this equation is used to model height-time relationship for anything that is dropped on Earth. And so the negative 16 refers to gravity, t is time, and the beginning h is the current height, h naught, or h sub 0, is the initial height. So the first h would be the height after a minute, or the height after a second. So that is this h. This h is your initial height. So we're going to use that equation to figure out how long it's going to take a penny to drop from the top of the tallest building in the United States. So h equals negative 16t squared plus h naught is our equation. So I'm looking for how long. So I'm actually looking for time. So my initial height is it's falling from 1,450 feet, and we want it to hit the ground, and so the final height's going to be 0. All right, so here we go. So there's my initial height, my final height, and I want to solve for time. I'm going to subtract 1,450 from both sides. So I'm going to switch it around. Negative 16t squared equals negative 1,450. Let's divide both sides by negative 16. So I get 90.625. And then we're going to square root both sides. And we're going to get, now we should put plus or minus, but because time cannot be negative, there we go, 9.5197 seconds. Now, the next question is how fast is the penny going to be traveling when it hits the ground, and it gives us an equation, and so all we have to do is put in our time. So I'm going to leave that in my calculator and just multiply by 32. And the speed is going to be 304.63, and this is going to be in feet per second. Alright, so hopefully you either learned something or remembered something from Algebra 1. Let me know if you have questions.